Hi, Algebra 2. This is Unit 2, Lesson 6 on inverse functions. So we're going to start off by doing an example, which is a composition of functions, and that will hopefully show you what inverse functions are. So example 1, we're going to consider the two linear functions given by the formula. So f of x equals 3x plus 7 divided by 2, and g of x equals 2x minus 7 over 3. And they want me to calculate f of g of negative 1. So remember, I'm starting with those inside parentheses, and I'm going to do g of negative 1. So in the g function, I'm going to substitute in negative 1 for x. So it's instead of 2x minus 7 over 3, it's 2 times negative 1 minus 7 over 3. 2 times negative 1 is negative 2, minus 7 is negative 9, and negative 9 over 3 is negative 3. So this now gets substituted in for f. So I'm going to do f of negative 3. This negative 3 now gets substituted into the f function. So f of negative 3 is 3 times negative 3 plus 7 over 2. 3 times negative 3 is negative 9 plus 7 is negative 2. And negative 2 over 2 equals negative 1. So if you notice, I'm starting with g of negative 1, and I'm ending up with negative 1. So g of negative 1 equals negative 3, and f of negative 3 equals negative 1. It's sort of like I'm plugging in negative 1 for g, and then I'm taking that and plugging it in to the f function, which gives me back my negative 1. Let's look at b and see what happens. So again, I got g of 5, so I'm going to do g of 5, which is 2 times 5, which is 10, minus 7 over 3. So that's 3 over 3, which is 1. Now I'm going to do f of 1. F of 1 is 3 times 1 plus 7, which is 10, divided by 2 is 5. So if you notice, I'm starting with g of 5, and I'm ending up with 5. The f is basically undoing what g did. These two functions are inverses, and this is what we're doing today. We're doing inverse functions. These two functions are inverses because they are literally undoing each other. What is an inverse function? An inverse function, if a function f of x has an inverse that is also a function, then we represent it as f negative 1 of x. And this is a little bit hard to see, so let me just write that for you. And that's f to the negative 1 of x. That's how I represent the inverse. Okay, facts about inverse. Graphically, an inverse is found by switching the x and y value in each point. Switch the x and y value in each point. That's how I do it graphically. Algebraically, I also switch the x and y, but then I have to do a second step. I have to solve for y. All right. So let's give an example. I want to find the inverse of h of x. H of x is, the points are 1, 2, negative 3, 4, and 5, negative 6. So the inverse, which I represent as h to the negative 1 of x, all I do is I switch the x and the y. So instead of my point being 1, 2, I'm going to flip-flop these around, and it's going to be 2, 1. Instead of my point being negative 3, 4, I'm going to switch those around. It's going to be 4, negative 3. And instead of the point being 5, negative 6, I'm going to flip those around, and my point's going to be negative 6, 5. And that's it. Those are the inverses. You're switching the x and the y. All right, looking at 3. Find the inverse of each relation. So 3.4 and 30, I'm going to just flip those around, and it's going to be 30 and 3.4. 5 and 40 is going to be 40 and 5. 7 and 50 is going to be 50 and 7. And 9.2 and 60 is going to be 60 and 9.2. B. So this one is actually not a function, it's a relation, but that's okay because it told me that in the beginning. Just show you that all I'm going to do is switch the x and the y's. So I got my input and I got my output. And I'm just going to switch these around. So my inputs are going to be the 38, the 40, the 50, and the 75. My outputs are going to be the 0, the 24, and the 34. So I just got to match them up. 36 went to 38, so 38 goes to, oh, I wrote the wrong number here, sorry. This should be 36. So you see 36 went to 38, so now 38 is going to go to 36. And 24 went to 40, so 40 is going to go to 24. And 24 went to 50, so 50 is going to go to 24. 0 went to 75, so 75 is going to go to 0. All right, let's look at a graph on the next page. Graph and label the inverse, f to the negative 1 of x, the inverse of f of x on the coordinate grid. So if the points of f of x are 0, 4, 2, 5, 4, 7, and 5, 9, the points for the inverse, I'm just going to flip these around. 4, 0, 5, 2, 7, 4, and 9, 5. All right, let's graph the original ones. I'll do the f of x in, let's see, blue. So f of x will be in blue. So I got 0, 4. 1, 2, 3, 4 is right there. I got 2, 5, which is right there. I got 4, 7. Let's see, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. And I got 5, 9. 2, 3, 4, 5, 9. Okay, so that's my graph. And then I will keep the inverse in purple. All right, so I'll do that in purple. So my points are 4, 0, 1, 2, 3, 4, 5, 2, 5, 2, oops, 7, 4, 1, 2, 3, and 9, 5. Okay, and there's my inverse. What simple reflection is happening to find the inverse? If you remember back from geometry, and I will put this in a different color, we'll do green. All right, remember the graph y equals x is this line right here? So that basically is a reflection over the line y equals x. Which makes sense because if you remember from last year when I did a reflection over the line y equals x, the x and the y just flip-flopped. All right, so let's find the inverse of each function. I have g of x equals 3x plus 5, so now I'm going to do this with an equation. So remember that the rule was you switch the x and the y. So instead of writing g of x, I'm going to change that to y. So step 1, you switch the x and the y. Okay, so I put x here and y there, and now I'm going to solve for y. So I have to get y by itself. So I'm going to subtract 5. And then I got to get y by itself. I'm going to divide by 3. So basically, y equals x minus 5 over 3. And if I want to write that as the inverse, I can just put back in that g of x, but it's g to the negative 1 of x equals x minus 5 over 3. And that's my answer. Try B. Again, I'm going to put a y in. Y equals negative 1/2 x minus 2. I'm going to switch the x and the y, so that's step 1. And now I have to solve for y. I need to get the y by itself. So I'm going to get rid of that 2. So I have x plus 2 equals negative 1/2 y. And to get y by itself, I am going to multiply by -2. All right, so I'm just going to flip this. I'm going to take the reciprocal. So I'm multiplying by -2. And when I do that, I will use the distributive property. Whoops. Let's see. I'll use the distributive property right here. All right, and I will get y equals -2x minus 4. And then I can write that as in the function, the inverse notation. Right? We'll try C. So C, again, y equals 10 minus 6x over 5. I'm going to switch the x and the y. I'm going to get y by itself. So I'm going to actually just put a 1 here, and I'm going to cross multiply. So 5 times x is 5x, and 1 times 10 minus 6y is just 10 minus 6y. Solving for y, I'm going to subtract that 10. So I have 5x minus 10 equals -6y. And then to get y by itself, I'm going to divide by -6. So basically, I'm going to have the inverse, m to the -1 of x equals 5x minus 10 over -6. So we're really just playing around with this. You have to be strong in algebra in order to manipulate these. So D, I have y equals, D is actually going to be tricky. Y equals 5 plus x over 6 minus 2x. Because when I switch the x and the y, I'm going to have two y's. So that's the tricky part here. So I have 5 plus y over 6 minus 2y. Okay, I'm going to put a 1 under here, and I'm going to cross multiply just like I did before. So I have 5 plus y equals, and I'm multiplying x times 6 is 6x. X times -2y is -2xy. I'm going to bring the 5 over to, I want the y's all on one side. I got them on this side and this side. So I'm going to bring this 5 over to the right, and I'm going to bring this -2xy over to the left. So it's going to be y plus 2xy equals 6x minus 5. So again, I took the 5 and I brought the 5 over to the right, and I took the -2xy and I brought it over to the left. Now what you have to do, so this is going to involve a second step, I'm going to factor out the y. Notice there is a y here and here, so I'm going to factor that out. When I pull out the y, I'm left with 1 plus 2x equals 6x minus 5. Now I can solve for y, because it's factored out. I'm just going to divide both sides by 1 plus 2x. And I finally did it. I got that y by itself. I'm sort of running off the page here. So I have 1 plus 2x. So I'm left with y equals 6x minus 5 over 1 plus 2x. If I want to write that in my function notation, b to the -1 of x equals 6x minus 5 over 1 plus 2x. And that would be my answer. Okay, and number 6, to determine if an inverse is a function, use the horizontal line test to see if the function is 1-to-1. All right, so remember, to do the inverse, I'm switching the x and the y's. So if I want to know if the inverse is a function, I use the horizontal line test. So basically, if the function is 1-to-1, then the inverse will also be a function. Okay, if the function is 1-to-1, then the inverse will also be a function. So if I want to know if each of these inverses is a function, I do the horizontal line test. So I'm going to draw a horizontal line. Okay, and there are multiple y. So this is not true. This is false. It is not. The inverse is not a function, all right, because it failed the horizontal line test. Inverse, not a function. The one in the middle. Let's do the horizontal line test. Okay, it passed. So true. The inverse would also be a function. Remember, the horizontal line test shows us if a function is one-to-one. If it's one-to-one, that means the y is not repeating. If the y's aren't repeating, then the inverse will also be a function. And the one on the right. Let me draw a horizontal line, multiple y's. So false. The inverse is not a function. Inverse, not a function. Okay, and I just have a little bit more. I know this was a long lesson. There was a lot. Just to show you different examples, not that it's hard. This is more like a little summary over here. So complete each statement. The domain of f of x is the range of its inverse. Remember, I'm just switching the x and the y. The range of f of x is the domain of its inverse, because I'm switching the x and y. To find the inverse of a relation or a function, I switch the x and y. All functions have inverses, but only one-to-one functions have inverses that are also functions. And then here's my summary. So the function, I'm going to call it f of x. The inverse is f to the negative 1 of x. In set notation, all I'm doing for the inverse is I'm going to flip-flop the x and the y. So my point is going to be negative 2, 2, 0, 3, and 2, 4. Nice and easy. Just switch the x and the y. Algebraically, I have to switch the x and the y and then solve for y. And divide by 2. So basically, it would be, x plus 13 divided by, I lost my equal sign. Let's start over right there. Okay, so it would be x plus 13 over 2 equals y. So just to write it as an inverse in inverse notation, x plus 13 over 2. And then graphically, my points for this graph are negative 1, 0, 0, negative 1, and 3, negative 2. So then the inverse is going to be the exact opposite. So this is, we can just call it f of x. So my inverse, my points will be 0, negative 1, negative 1, 0, and negative 2, 3. Okay, so 0. This one's hard to see because they're sort of on top of each other. So 0, negative 1, because some of the points are similar. Negative 1, 0, and negative 2, 3. 2, 3. Okay, so it just goes this way. All right, and that was inverses.